Okay, so what we learned in the introduction video is that we can calculate the speed for each part of the journey using the formula speed equals distance over time. So we found that the speed during part 1 was 0.5 meters per second, the speed during part 2 was 0 meters per second, the speed during part 3 was 1.75 meters per second, the speed during part 4 was 0 meters per second, and the speed during part 5 was 4 meters per second. Then we finally said if we want to closely align speed with the slope of the line rise over run, we need to acknowledge that a negative slope means speed in the opposite direction. This is called velocity. So we said the velocity of the return journey was minus 4 meters per second, indicating the return journey. Okay, now what I really want to focus on now is the fifth part of the journey when she runs home. So if I think about this reasonably, she starts running from a standing position. So it is more likely she needs to build up her speed than she starts straight away at 4 meters per second and continues at 4 meters per second. So here what I want us to think about and acknowledge is that actually what we are finding is her average speed over those 10 seconds. Okay, so that's an important distinction to make here, and a real extension of our knowledge that really the formula speed equals distance over time would be more accurately said as average speed equals distance over time. Okay, so that's what we're going to continue with here, is that we are finding the average speed with that formula. Okay, so now Tara has a speedometer, and this time she is going to track her speed against time instead of her distance against time. This is called a speed time graph. So we still have time here on the horizontal axis, but this time along the vertical axis we're measuring speed in meters per second. So looking at her journey, part 1, she steps onto the path and walks for 10 seconds. So we calculated she had an average speed of 0.5 meters per second there. So what we need to do is we need to go to our graph and find 0.5 meters per second on the vertical axis, and we need to represent that for those 10 seconds. So from 0 to 10, we need to draw a horizontal line to represent that she had a constant speed of 0.5 meters per second for those 10 seconds. Okay, so then part 2, she stops for 5 seconds to read a text on her phone. So she stops, which means she is still, so we know that she has an average speed of 0 at that part. Okay, so to represent that, find 0 meters per second on your vertical axis, and you're going to have to represent that for 5 seconds. So to do that, draw a horizontal line for those 5 seconds between 10 and 15, and that shows we had 0 speed for those 5 seconds. Okay, then part 3 of her journey, she skips for 20 seconds along the path. So we calculated an average speed there of 1.75 meters per second when she was skipping. So to put that on our graph, find 1.75 meters on your vertical axis, and we're going to have to represent that speed for 20 seconds, from 15 to 35 seconds. So all along here, we're going to have to draw a horizontal line showing a constant speed of 1.75 meters per second for those 20 seconds. Okay, then the fourth part of her journey, she stops for 15 seconds to answer a call from her mum. So again, she has stopped, which means she is still, which means she will have no speed. Her speed will be 0. So back down to speed equals 0, and we're going to have to draw a horizontal line for 15 seconds that she was on the phone. So draw a horizontal line here from second 35 to second 50. Okay, and then the last part of her journey is her mum actually told her that she forgot her maths book, so she runs home. Now we calculated an average speed for that run of 4 meters per second. So find 4 meters per second on your vertical axis, and draw a horizontal line for those 10 seconds, from second 50 to second 60. And as we talked about, that horizontal line is representing either a constant speed for those 10 seconds or maybe an estimation using average speed for those 10 seconds. So an extension of our knowledge there would be that a horizontal line represents either constant speed or it represents an estimation using average speed. Okay, so what do I mean that the average speed could be used as an estimation? Let's focus on the last 10 seconds where Tara runs home. We know her average speed is 4 meters per second, so we are going to do an investigation. Okay, let's look closer and break it down to 1 second intervals. Using speed equals distance over time, we can calculate the average speeds for each second. Okay, so for second 1, she's traveling at 1 meters per second. For second 2, she's traveling at 1 meters per second. Second 3, she's traveling at 2 meters per second. Second 4, she's traveling at 4 meters per second. Second 5, she's traveling at 4 meters per second. And are you watching the graph how it's tracking out? For the 6th second, she's traveling at 5 meters per second. For second 7, she's traveling at 5 meters per second. For second 8, she's traveling at 5 meters per second. For second 9, she's traveling at 6 meters per second. And for second 10, she's traveling at 7 meters per second. Okay, so if you look at this shape now that we have drawn with those 1 second intervals, this shape is more closely aligned with what we imagine happens when you run. So you can see here, at the beginning, she is starting slower at 1 meter per second, 1 meter per second, 2 meters per second. That's because she's starting to run from a standing position. So it's going to take her a while to get up to full speed. So you can see her speed keeps increasing until she gets right up as far as 7 meters per second. Okay, so this shape here is more closely aligned with reality. And you can see that, I guess you'd call it a curved shape. And it's more realistic than maybe this line that gives us the average speed over the 10 seconds. But it's a very good approximation, isn't it? Now, if I look at all of my speeds here for those 10 seconds, what I can do is get my average speed over the full 10 seconds by adding all of those together and dividing by 10. So let's add up all of those numbers together, and you can see they add up to 40 meters per second, and we've got 10 intervals, so divide by 10 to get the average, and we get the average speed over the full 10 seconds is 4 meters per second squared, which is exactly the answer that we had for our average speed of part 5. Okay, so let's take an even closer look and break it down into half-second intervals. What you can see from the graph is now that the graph is getting more refined and more curvy. Okay, in fact, if we take even smaller intervals, like say 1/10 of a second or 1/100th of a second, the graph will continue to be more curved and more fluid. Actually, during leaving cycle, you will investigate speed using really tiny intervals. This is called the study of calculus. So just like on our distance time graph, a closer look at speed often reveals a curved shape too. Here is a speed time graph, time on the horizontal axis measured in seconds, and speed on the vertical axis measured in kilometers per hour. Now the graph here is modeling the speed of a car against time from a stopped position at traffic lights, then getting a green light and proceeding with its journey. Now if a car is starting from a set of traffic lights, think about it. It will take some time for the speed to build up. So the car is gaining speed from 0, and you see it gaining speed And that's represented on our graph as a curved shape as it keeps gaining speed. Okay? And then here we can see it took 21 seconds to build up to a speed of 87 kilometers per hour. Okay. So what you can also see then is that there's a speed limit here on this section of road of 100 kilometers per hour. So the driver decides to set the cruise control at 87 kilometers per hour to sit at a constant speed comfortably under the speed limit. So you can see that here, that constant speed is going to be represented as a horizontal line, whereas the seconds keep moving, the speed continues to be at 87 kilometers per hour because that's how the driver has set it. Okay, so this is where we can see that a horizontal line can represent a true constant speed and not just an estimation using average speed. So we'll know the difference really by the context of the question. So I hope that this helps you as you look at the different styles of questions. Okay.